So the talk I'm going to present is a final paper in a sequence of papers I have published on the realism debate. I began with the numericals argument, the pessimistic induction, provided a new version actually thereof, and thought hard about why and to what extent quantum mechanics maybe has to do with the realism debate, because some people just say that, some people say this is absolute nonsense. I tried to offer a decided argument, and now I'm even trying to do something about real holism and underdetermination, which is another classic. So I like the classics, and I try to put new life into them in these papers. Good, so let's start with some things that you basically already know, I think. In the aim and structure of physical theory, Duhem told us that the physicists can never subject an isolated hypothesis to experimental test, but only a whole group of hypotheses. But he said, in condemning one system as a whole by declaring it stained with error, the experiment does not tell us where the error lies. So the suggestion kind of being like there could be many different kinds of groups of theories that would be compatible with the whole evidence. It just modifies some stuff. I can get a new system, and so I don't really know which system it is. Quine famously endorsed, well, something on top of that, but also the same thesis to a certain extent. Says our statements about the external world face the tribunal of sense experience, not individual, but only as a corporate body. And furthermore, any statement can be held true, come what may, make drastic enough adjustments elsewhere in the system. So these are statements of holism. The first one is basically a statement of holism. The second one basically of underdetermination. I just modify my theories enough, I can come up with lots of different systems that are all compatible with the existing evidence. Yeah. Right, that's what I just said. And the common law is that conformational holism and underdetermination together pose a threat to scientific realism. The thesis that we just saw consists of the metaphysical stance that there is a reality, the semantic stance that we can make reference to that by means of scientific theorizing, and the epistemic stance that we, or commitment that we kind of know something about reality via scientific theorizing. But how exactly does it work? What exactly is the threat to realism? That was never really clear. For instance, Samir Akasha had a paper where he basically says, well, look, if you take holes into account, then special relativity emerges as a special case of general relativity, and which is not true of ether theories, of Lorentz Fitzgerald ether type theories. And so holism sort of resolves the underdetermination between the two. It's clear which of the two we should accept, because it's only SR that emerges as a special case of GR. So holism actually counters underdetermination in some cases. Yeah? The purpose, the agenda, oh, I'm not seeing what my headings here. The agenda for today is to try and propose, that's the problem. Propose and argue for a stronger variant of holism, and then to show on the basis of this how underdetermination feeds into it to create a threat for realism. And finally, I will try to dispel a potential response, which is the one from selective realism, which I think is the one that makes the most sense, but I think there's a good reason to be skeptical about it anyways. Good. Here's the structure of the paper. It has three separate arguments that all feed into each other to create like this overall challenge for realism. The first, well, the most important premise of all this is what I call local conformational holism. And it says that the logical semantic parts of a sufficiently general and substantive scientific hypothesis can only be confirmed via the confirmation of the hypothesis as a whole. You can kind of see why this is the statement of holism. I'm saying it's only the full hypothesis that can be confirmed, not the parts. You can also see why it's called local, because it's only about one specific kind of hypothesis or theory. It's not about a whole group. Yeah? And basically saying the holism problem is already there at the level of a single scientific hypothesis, as long as it's sufficiently general and trying to make claims about what reality is like. Yeah, so this is what the terms mean here. Logical semantic parts basically means non-trivial entailments. So the stuff that is entailed by what I'm saying is kind of part of the content of what I'm saying. There's some kind of trivial entailments that really don't interest us, like just adding a disjunct or something. That's not what I mean. Substantive here means I'm evaluating the theory or hypothesis not just as a tool. So I'm saying if we presuppose realist semantics, then we are only facing the problem, because then it's about the claims that the theory seems to be making. We're not just using it for calculations. We want to endorse what it says. And finally, general. Well, some kinds of hypotheses might be immune to this kind of threat, because if I just inductively generalize, then maybe I just keep encountering the same kinds of entities with the same kinds of properties, and I can confirm something. If it's general enough in the sense that it concerns many distinct phenomena, makes claims about distinct phenomena, then I think we're already at the level where this holds. Of course, I will have to argue for why I think this is true. And scientific means it must be precise enough to allow some kind of test. It must be formulated in language that is precise enough to say what the theory really says about reality. Good. The first argument then says, well, let's assume that this local confirmational holism is true. Then, of course, it's a provable fact that the degree of confirmation of the whole hypothesis is always limited by the confirmation received by its parts. It's just a basic fact of probability theory. If you think of confirmation in terms of probabilistic relations, like evidence makes it more probable that the hypothesis is true, this is just a mathematical fact, basically. Yeah. But the conclusion then is, if the confirmation of the whole hypothesis does not increase the degree of confirmation of one or more of its parts, then so long as this here is true, yeah, that we can only confirm the parts by the whole, the confirmation of the whole hypothesis itself is also bounded by the lowest prior probability of all those parts. In other words, I can't confirm the hypothesis any more than I already believe what it says in certain respects. Well, okay, Florian, if, yeah, I mean, come on, yeah. We know that the confirmation of, we know that hypotheses are being confirmed, and of course, it's increasing the credibility of their parts, obviously, right? Call that holistic top-down confirmation. So you confirm the whole, and then from the top down, you confirm the parts as well. But against this, I want to propose the following second argument. There might be some necessary conditions for doing this kind of top-down confirmation from the whole hypothesis to its parts. For example, you might want to request that increases in the degree of confirmation of an overall hypothesis can only increase the degree of confirmation received by any given part of that hypothesis if the evidence does not, the same evidence does not speak at least equally in favor of a different hypothesis, which does not have that very part. Yeah? If I can do away with the part, I should not say the confirmation of the whole also confirmed that part, obviously. However, the underdetermination problem basically tells us that very often evidence does speak, at least for certain periods of time, in favor of different hypotheses which do not contain all the same parts. And so long as this is true, typically the increases in the degree of confirmation of an overall hypothesis cannot increase the degree of confirmation received by some of their parts of that overall hypothesis. Yeah. Good, so what's the threat for realism here? Why is this so slow? If we conjoin these two conclusions, of course, we get the implication that typically the confirmation of hypotheses is bounded by the lowest prior of their parts. Not just if blah, blah, blah happens. As a matter of fact, this is true. So in other words, we are only ever entitled to believe substantive scientific hypotheses to the degree to which we are antecedently committed to what they entail. Okay, but yeah, come on. So maybe we can just confirm some parts of these hypotheses. So maybe this is true about the whole hypothesis. Maybe there's some problematic parts, but there must be something which we can confirm, right? And this is, of course, the response from selective realism. And we can say, well, right, there's some stuff that we can't be certain about, and that limits the confirmation of the whole to a certain extent. There's some stuff that just stuck with us for a long time, and we want to believe that, like atomism, for instance. So here's my response to that, which is the third argument of the paper. It has the first premise that if the logico-semantic parts are sufficiently general and substantive scientific, so hypothesis at the right level, can only be confirmed by the confirmation of the given hypothesis as a whole, then selective scientific realism inevitably requires confirmation by meta-empirical evidence. Yeah? I will try to convince you of that in the last part of the talk. However, local confirmation holism basically says that the antecedent of this is true. So therefore, the conclusion here is that selective scientific realism inevitably requires confirmation by meta-empirical evidence. Yeah? So you might go like, so one's modus ponens is another's modus ponens. Somebody might say, well, okay, so be it. That's good for a meta-empirical confirmation, right? But some of us have reservations about the possibility to confirm something just by looking at the context of inquiry instead of confronting actual scientific evidence in the field or in the lab. And so for those of us in disfavor of meta-empirical confirmation, this maintains the anti-realist threat to confirmation. So let's see why the premises are plausible at all. Let's first start with this premise DEC, which is short for degree. The degree of confirmation of an overall hypothesis is limited by the degree of confirmation of its parts. This is just basic probability theory / Bayesian confirmation theory. Yeah. If we accept this well, at the very least, half of the Bayesian theory of confirmation, that if we have confirmation, we can model this by an increase in probability of a certain hypothesis based on evidence that we have received. We get the evidence, and we conditionalize on it. Here, this is the definition of conditional probability. So if you think in terms of cases, we check how many cases of the evidence occurring are also cases in which I have to take the hypothesis to be true. And so this frequency, if they are normalized to the same number of total events, then the frequency of this would be increased here. Yeah. Furthermore, there's a well-known theorem. For instance, you can find a version of that in John Ehrman's Bayes or Bust. You have this convergence in the long run. If you have different pieces of evidence which are mutually independent of each other relative to the hypothesis in question and its negation, and which all increase the probability of the by themselves increase the probability to some degree of the hypothesis, so which have this confirmatory impact. And if you just keep piling up that kind of evidence in the limit of infinitely many pieces of evidence, you will have absolute certainty. Yeah. Good. I mean, this could take forever, but at least it's a nice model that shows you that at some point there might be a reasonable point at which you can say, I'm pretty confident I've seen so many independent pieces of evidence that don't depend on each other if I just accept the hypothesis or its negation, either or. It's just very reasonable to accept this hypothesis based on all that evidence. It's a nice model of how our modes of confirmation work just in mathematical terms. But here's an observation that I got from a talk by Gerhard Schulz some years ago in the EFSA on a paper with Schippers, I forget his name, Michael Schippers also. And here they point out that, and this is just something very obvious, but they pointed the finger at it. Yeah, if you have some sort of entailment C of some hypothesis, or content element if you want, that is not confirmed by any one of the evidences CI, this is sufficient to prevent convergence to certainty. And if there's one part of the hypothesis which is entailed by it, something that's entailed by the hypothesis, which does not receive confirmation, and you just don't get to certainty. Yeah. Why is that? Well, the probability of that part is not raised by any of the evidences, so you just get back the prior probability for the part, obviously. However, because H entails C, it's not very complicated to show that the probability of H given all these evidences cannot be greater than the probability of C given all these evidences. It's just a mathematical relation that you can show in the probability calculus. But just saw that this is just the prior, and so the confirmation received by the hypothesis is just bound to stay below the value of C, of the probability for C. So below the degree to which we already believe the part. Just primitive facts from confirmation theory. Good. In classical logic, you have some things like this is entailed by every hypothesis, H or not the evidence, and then you can show that this is not being confirmed, and so this is kind of a trivial problem. To make it non-trivial, Schulz and Schippers suggest a kind of relevant entailment, which mostly means that there should not be any predicates in this part, for instance, which can be simply replaced, and then still the inference goes through. So you kind of just subtract these kinds of cases, and say there should be a connection on the level of content between the part and the hypothesis. It can be just logical consequence in general, but needs to be limited. They call these content parts, or the most primitive ones, content elements. I will adopt this terminology in the fall. Okay, so much for the premise degree. If we have some interesting part that's being entailed, that's a problem if it's not being confirmed by the evidence. But why would it not be confirmed by the evidence? Here is where local confirmational holism comes into play. Or why are there limitations to the confirmation? Take an example from physics, the Maxwell equations. I think they're an excellent example of a hypothesis at the right level of generality, and for another reason they're also interesting. Okay, don't get scared here. This is a mathematical formula which theoretical physicists present them. You have two kinds of fields, the one which is the electromagnetic field, the other which is the current, so basically charge carrying particles. Charges moving around in space. And here you just have a dependency of the changes of the field on the currents, and certain changes in the field cancel out. Okay, so here this is not really a statement. This is just a formula because it doesn't have any quantifiers, so it's not really a statement. What would be the correct form? I think it would be something like this. There are things which are these fields, and they have a specific mathematical form called tensor fields of a certain rank, different kinds of tensor fields, such that for all things in something called a space-time manifold, so something which is space and time, and we describe it somehow mathematically. And for all numbers between 0 and 3, the following relations hold. Yeah? The interesting part about this is when you construct it thus, it's not problematic to show that these two existence claims are part of the content of the Maxwell's equation, taken as a scientific application. It says there are things which are these kinds of fields, well described as tensor fields in mathematics. There is something out there, this is the substantive part, there's something out there which is well described by this kind of mathematics, and it exists. So now the question is, could we confirm this existence claim in isolation? You might kind of feel like, well, how are you going to confirm this? And I think this is exactly right. I mean, how do we confirm anything at all? Let's take the Maxwell equations again as an example. For example, something that you do in your physics lab course, which I thought about, you can derive this kind of formula here from the Maxwell equations. And this is a bit more concrete. It says that the magnetic field at some point in space X is proportional to some function of the current in a wire. Now, the current in a wire produces some sort of magnetic field. And this is what the dependency is according to the Maxwell equations. Then you can just measure something in the lab. Yeah, and here glossing over the traditional problem of holism, of course. Yeah, you might be able to establish that B takes on the value M. I've seen all sorts of ideas about how the measurement works and so on. Let's forget about that for a moment because it makes the challenge only worse, and I'm interested in granting the results as much as I can. And then if you derive a very similar value to this measurement here from the law, then you plus some boundary conditions and so on, then you could say like, okay, so the Maxwell equations predict this value, yeah, deductively in a sense, and thus they're confirmed by that, yeah. Good, but could we do this for C alone? No, obviously, well, it doesn't have an implication of that sort, right? It doesn't have a lot of implications. It has basically hardly any implications because that should be beyond the two existence claims. So like this classic route, which Ludwig also partly endorsed, like deducing something from the theory and thereby getting for free the confirmational relation, that doesn't work. How else could it work? Well, implication might be the culprit. Maybe this is too narrow. Yeah? We don't have to deduce it from the theory. Maybe there just has to be some sort of probabilistic relation. So maybe for some other reason, the fact that something was measured makes the existence of the fields more probable. Or maybe this is the most interesting case here. Maybe the postulation of these fields makes certain measurement claims more probable, and then from Bayes' theorem you also get confirmation. Yeah, this is the only two routes I think that are possible here. Good. Let's consider this claim here. Yeah, as soon as somebody tells you, well, you've measured blah 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 in the lab, isn't that value? So there are two fields out there in space-time, which can be described as tensor fields. You would immediately say, we're just considering this in isolation right now. Yeah, immediately you would say like, dude, how do you know that? Yeah, well, how do you come up with a relation between this measurement and the bare existence of something out there which we call a tensor field? You would want to have more information. That would be the rest of the Maxwell equations, of course, or some replacement of that relates F and J to each other, the current and the field. So you would immediately wonder, what else do they know? This doesn't seem viable, yeah, without further information. If you just try to consider it in isolation, you need more stuff. You need to embed it in a broader hypothesis. Good, but so maybe we can somehow justify that the assumption of certain fields out there makes it more probable that certain measurements occur. Yeah, maybe we can fold in some kind of model of the measurement and that gives us a kind of statistic like a Gaussian or Poissonian or whatever, and then we somehow see that there's an increase in the probability of the measurement if we condition on the claim that there are these fields. But yeah, yes, this is what I said. But again, the question would be, how is this possible? If you just say there are some fields out there, there's just no connection to any measurement. Yeah, it's not enough content. You need more. You also need some sort of relation that tells you what kinds of models of the measurement are plausible, because you want to know how these fields would interact with your measuring devices. So I think this makes it extremely credible that this local sort of holism is present in every scientific theory. You just can't extract the parts and then confirm them in isolation. You have to do something more sophisticated. Yeah, you need the whole or you need another procedure. Is this only a problem in physics? I don't think it is. I will just very briefly mention this. So, for instance, the price equation, which something is a rather fundamental equation in evolutionary theory, can be confirmed in a very similar way. Like you derive the Breeder's equation as a special case from it, and you impose some certain causal constraints which act like some condition. Then you see the set of Breeders, and using this as a confirmation somehow of the equation because it sort of follows a special case. But it has certain choices of variables in there, certain mathematical choices of description of what fitness is and so on. And so you're kind of, again, committed to a kind of existence case that there's something which is fitness and which satisfies a certain mathematical form. Yeah. Is it only mathematicized science? I don't think so. But yeah, consider the case of plate tectonics. So in principle, you could make the same move. You could say like, well, what's the nature of these plates? Yeah, you always have to come up with a certain kind of story, and that tells you something about the dynamics, and only from that you get to the evidence. So there's many parts that depend on each other for the possibility of confirmation. But even if you say like, come on, this is a very weak claim, yeah, it's becoming very weak. You're going on a limb here, Florian. Maybe you're right. Maybe it's much more problematic to show this in this soft case, but it's also because the confirmation here is also much more problematic, yeah, because the relations are not so clear between the hypothesis and the confirming evidence. But even if you reject it in this case, a lot depends on mathematicized science. For instance, electrodynamics was absolutely crucial for the discovery of tectonic plates, because you had these magnetic stripes and so on. You had to know a lot about how to make measurements of magnetic fields in order to gather evidence for plate tectonics in the first place. Furthermore, normally there's a degree of impressiveness that comes with only with mathematization. Look, you also talked about this. If something's very surprising, the correspondence between theory and evidence, this is only possible if you have mathematicized science. Yeah? So people here in the plate tectonics community say, to become testable, plate tectonics needs to have mathematical elements like spherical geometry, spherical mathematics, and even unit quaternions. So fancy mathematics actually to make some very tangible predictions that you could test whether they're true. Good. So I think this is a quite general challenge because it attacks at such a general, because there's dependencies of sciences on each other. It attacks at a very general level of scientific theorizing, and I think it might be conferred to all kinds of sciences. Good, but now what about this possibility of confirming stuff top down, like confirming a whole hypothesis and then saying, okay, so this kind of confirms all the parts that are contained in my hypothesis. Here's where underdetermination finally develops its bite, I would say. Gerhard sort of was aware of this problem, or not exactly this problem, but that there might be some problems with this account of confirmation. And he says there should be two necessary conditions for confirming a part of a hypothesis by evidence, or this content element of a hypothesis that is being confirmed by, whether a hypothesis being confirmed by some sort of evidence. You have to transfer from the hypothesis as a whole to the content part. It says two things are necessary for this. For instance, this content part has to be necessary within the hypothesis to make the evidence probable. So you couldn't just have a conjunction of other elements of H that make the same kind of evidence probable. Yeah. Okay, but this is only within the hypothesis. It can be a superfluous part of the hypothesis that you can extract and throw away. Second thing that he imposes, well, the content part can be just an existential generalization in a way of quantification, so that you have H by fitting the variables contained in H, where you say, there's something that satisfies blah, 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 and it will fit something until I get evidence E. And I could equally fit the something to get very different evidence, yeah, a very different kind of evidence, maybe even the opposing evidence. If this is your content part, this is a problem. Should not be confirmed. Like at this level of generality, you could say, well, God wants us to blah blah blah, and I will always fit what God wants us to do until I get the evidence wrong. Makes sense, but are they jointly sufficient for this holistic top-down confirmation? It's just necessary conditions. Yeah, this should be given. This should be given. Only if they're given, you can start confirming the parts. Yeah. Oh, okay, let's do that. So I'm saying should be at least a third condition, that we also don't have an alternative hypothesis, which is also confirmed by the evidence, but doesn't have this part as a part. If there's a rival, yeah, that can do without the part and is confirmed just as well, then this is a problem too. Yeah, we should also say the part has not been confirmed. I'm not going to go into this, but of course, transient cases of underdetermination suggest that this keeps happening over and over. We don't know exactly whether some sort of quantum gravity is going to be the new thing, or string theory, or one of the many string theories in the string theory landscape, or whatever. Yeah, and maybe you can just dispel some parts and get the same evidence out. Here's the most sensible response to this: selective scientific realism. For instance, Stathis Psillos has also against Stanford argued, well, I think we know already what this is about. We talked already about it in John's talk, which is good for me. I don't have to go through it again. And I just want to say, like, the parts could be structural parts, there could be entity claims, there could be causal profiles of these entities. I would be neutral on that. I would say, like, Kitcher and Silos basically nailed it when they said, like, we don't have to commit ourselves to a special kind of posit. It can be any kind of posit that survives the switch between theories and therefore has some sort of credibility to it beyond the theory itself. Good, but let's consider the Maxwell equations again. So as we said, like, in this way, it's just an open formula. They have survived the switch from classical to quantum electrodynamics, but we can't just say it's just a formula that we confirm because it's not a statement. It's just an open formula. So how do we even begin to confirm it? Maybe we can use unrestricted quantifiers, but if you look carefully, then we would just be saying there's something which has some kind of components and is a function of something is proportional to another function of whatever that something is. And how do you confirm that? That's not enough. Yeah. Another approach that I think is what many selective realists are suggesting is to just extend the scope of the quantifiers. You can run across a broader set. For instance, you could have different manifolds with different space-time dimensions, different structure, and so on. You're just open about that. And this is fine. Peter Vickers argues like that in some papers. It says like, well, the realist doesn't have to commit herself to this and that. It could be a broader claim, could be a more general claim, which has this as a special consequence under certain circumstances and so on. But where does it end? Yeah. To me, this is kind of an immunization strategy, as I've already argued in print, because you can always say like, well, the scope was just not broad enough. You just have to broaden it further. And then it's not clear what you're really committed to at all. Okay, so but how it could be a positive proposal for committing yourself to something? Well, you could take the very fact that the formula has survived the switch from CED to QED to be confirmatory of the formula. Yeah? Because it's in both. You see that it's in both theories. You say this somehow is true. Yeah? However I interpret this somehow is true. But if you look carefully, this is immediately an acceptance of meta-empirical facts because you're now talking about a landscape of theories and what we've come up with and how they relate to each other. You're not talking about the evidence anymore. So if you would take that as confirming the Maxwell equations, you would say it's the fact that they are in this overlap of these theories that so far have received confirmation for something else. Yeah? This is a meta-empirical fact. It's not an empirical fact anymore. Maybe you could try to evade this by watching together the collective evidence in support of the posit. So you might want to endorse the following principle. If some posit is a constant element of two distinct hypotheses, which are confirmed by two distinct pieces of evidence or kinds of evidence, then both these kinds of evidence will confirm the posit. Yeah, in virtue of the fact of it being in the overlap of the constant elements between of these two. I think this is a reasonable response. But the cool thing is that it can be shown that if you forbid that the acceptance of this principle itself makes it more likely for the select posit to become confirmed by the multiple evidences, then that the antecedent is true and that they have shared content at all. Yeah? And apply a very weak use of Van Fraasen's special reflection principle that you should gauge your credences for hypotheses as it were on your known future credences for these hypotheses. Yeah, in a situation which is by construction safe from pertinent counterexamples, then you can show that this ipso facto yields an instance of meta-empirical confirmation that the being in the overlap already confirms the posit itself. Good. So what to conclude from this? This was a mouthful. I'm saying that holism is present already at the local level of one substantive general scientific hypothesis. Together with some primitive facts about probabilistic confirmation and with transient determinations, I think is sufficient. This kind of gives us a challenge here that hypotheses cannot be confirmed beyond the degree to which we already believe they're parts of their contents. Selective realism is the most promising way out. It's a very reasonable way out in a way. But I think it only works if meta-empirical confirmation is being accepted on account of local confirmation of holism. And which quite reasonably might have to do more with pursuit than justification, but pursuit is totally fine with anti-realist approaches to science. You say, I can accept it, but I don't believe it. It just means I use it until I find something better. Thanks.